what sedimentary environments? We have terrestrial, and then at a certain point we start reaching the sea, and so we have transitional. And these will be your beaches, deltas, estuaries, and then we have fully marine. And marine will be shallow and will be deep. Terrestrial, we saw that it's dominated by fluvial systems. And I talked about at least the 3 different types of fluvial system. We had the alluvial fens, and those are very near to the source of the sediments, which is mountains. And then we have rivers. And I started drawing the fascias that one can find in 2 different river systems. One was the braided river system, and the other one was the meandering river system. So how do we distinguish the 2 when we go in the field? And remember, I talked about this term, fasces, and I already introduced you to the definition. So fasces is actually, it's a rock. And when it's a rock, it's called a lithofascias, because lithos means rock in Greek. And that rock will have sedimentary texture and structures which are typical of, well, the environment of formation. So fasces is a fossilized part of an environment of formation or deposition, or even in a sedimentary environment you can even have erosion. So erosion, transport, and deposition. What you do see is evidence of erosion, for example, channels, and then the deposition inside the channel. And one of the things I keep sort of telling you about is this stuff about a block diagram. Because a block diagram is a 3-dimensional representation on this light board, which is like a sheet of paper, of the model of a sedimentary environment. In a braided river system, where you have lots of channels, so this is the modern surface. Let's call it modern. And think that you are here today. Okay? Looking at this, you would have your braided channels, many channels, and this is why it's called braided. So water is flowing in the channels, and it's forming, by deposition, gravel or sand bars. So I put this gravel, and then you might have some sand here, gravel, some sand, and gravel, some sand, okay? Now, what happens is that here you have a channel, and the channel, because it is a channel, we have a little bit of an erosional surface, which I draw like this, like little zigzaggy things, okay? And what goes in the channel well, at the bottom of the channel you might have also some coarse sediment. So channels, but how do bars look like? Now this is kind of interesting because they would look like this. And you will have this and sand. Ha! Now here we are, okay, the current is flowing this way, that way, that way, that way. So it's flowing in different direction and it's depositing. So here, again, you will see something like this. But suppose that the current changed at a certain point in time and it was flowing this way. So parallel to here. Yeah. So on this side of your outcrop, you would see cross stratification because the bar advances in the direction of the current. Anyway, I also told you that this keeps shifting in time. So this is modern and this is 10,000. So maybe like 1,000 years ago, channel was somewhere else and bars were also somewhere else. So channels maybe here, maybe here, maybe here. So the bars are here. And here maybe you see again the cross stratification. So if you see something like that with stacked channels, we know, or I told you that this is most likely a braided river system. And where do we find a braided river system? Very near to alluvial fans, for example, near the front of glaciers, and where you have a lot of bed load, a lot of sediment is transported. If we move farther in our terrestrial system, I mentioned that we have the river the river system becomes different, becomes meandering. What did it do? First of all, it lost most of its gravel. It's got a little bit or nothing. It still might have some sand and some silt. And the channel is big, it's deeper, and it meanders. So it goes like this. And I mentioned that on this side you have deposition, and this side you have erosion, because the current goes like this. And here it's stronger and excavates, and here is weaker, and so it deposits. So what it does here is it builds progressively a point bar. Okay, so let's look at this in our block diagram. Remember that now I'm leading you into the meandering river system. The channel is asymmetric because here it's a road and here it deposits. So where it erodes, it's like this. And where it deposits, it's like that. And the point bar will look like this on this side. And it will have large cross stratification. And with large cross stratification, tell you that at time, let's see, this is modern, like 100 years ago, they could have been here, 200 years ago here, 300 years ago here. And this keeps migrating. It will be built, this is in the next 100 years it would move here, and then it will move here, and when it will move here. So what it does is the accretion of the point bar is not in the direction of the current, which is this, but it's somehow parallel. So it's called lateral accretion. What does this river do also is it floods and it will deposit the fine parts into the alluvial plain. So these will all be fine, but being an alluvial plain, it means that when the river floods, it might even cut through the levees, which are the little, at the flank of the river you have this kind of tiny relief. It cuts through and then it floods the alluvial plain, and it will transport, for example, a little bit of sand on top of the clay or silt. So here you have like coarser, and then here you will have finer. And at the bottom of the channel, you generally find the, oops, this is not right, you find the coarser material. Okay. So let's get to, okay, modern environments and something that you start finding in the geologic record. But I have drawn a block diagram, meaning something which is in 3 dimensions. So how am I going to see this in 3 dimensions? If I turn the corner here, I will see a lot of sand, for example. Now, if you go in the field, as normally geologists do, or if you are even less lucky than having outcrops in the field and you are drilling cores because you are looking for some resources, or you're looking for water, or you are looking for places where to store something, sometimes you don't have the possibility to see in 3 dimensions. So you don't know, if you turn around the corner, what you're bound to find. So how can you recognize a braided river system from a meandering river system? Here you have to sort of work out with this concept, fascias, and not just this concept of fascias.